Welcome to the Tilted Planet Podcast, sharing journeys, stories, and a little wonder from around the world. I'm Jack, your host, and today we're heading into the cold, quiet north, to a place where the night sky glows in motion, where ribbons of green, pink, and violet twist like smoke above silent forests and frozen lakes, a place where light itself seems to dance, not from lamps or fire, but from the heavens. It's one of the most mesmerizing natural phenomena on Earth, and for as long as people have looked up, it's filled us with awe, fear, and curiosity. This is a story of the Aurora Borealis, the Northern Lights. A story where myth meets magnetism, where the language of light reveals the restless power of our sun, and where even the most advanced science still leaves room for wonder. Imagine standing on a frozen plain thousands of years ago, before electricity, before telescopes, before even the idea of space. The night is clear, the stars sharp and bright, and then, without warning, the sky begins to move. A faint green glow on the horizon spreads upward. It ripples, bends, flickers even, until the whole sky becomes a living curtain of light, flowing like liquid fire. What would you think? A message from the gods? A sign from the spirits? Or perhaps the boundary between worlds cracking open for a moment? For early cultures, the aurora wasn't just light, it was meaning. The Sami people of northern Scandinavia believed the lights were souls of the dead, moving across the heavens. To whistle at the aurora, they said, was a dangerous thing. It could summon the spirits down to the earth, and they might take offense to that. In Norse mythology, the aurora was seen as a reflection of the Valkyries' armor, the warrior maidens who carried fallen heroes to Valhalla. The sky's glow was their shimmering passage, a celestial reminder that bravery lived beyond death. The Inuit of the Arctic told stories of ancestors playing games with a walrus skull, tossing it across the night sky. In some versions, the lights were spirits guiding the souls of the newly dead. In others, they were torches of hunters searching for the next world. And in ancient China, written records describe heavenly vapors glowing in the northern sky, sometimes red, sometimes white, often taken as omens of great change. Even in ancient Rome, historians like Pliny the Elder described flaming spears and bloody skies that terrified entire cities. When you think about it, it's easy to understand their fear. The aurora appears silently, unpredictably, a living, shifting thing that moves faster than clouds but yet slower than fire, painting the sky with colors no flame could ever match. Before science gave us answers, it gave us stories. And sometimes those stories still feel closer to the truth, because even knowing the science doesn't make the aurora any less magical. Now, it wasn't until the age of exploration that people began seriously to study the lights. In the 17th and 18th centuries, sailors venturing into the Arctic waters wrote about glowing skies. That seemed to follow their ships at that. The first person to give the phenomena its modern name was the French philosopher Pierre Gassendi in 1621. He combined two words, Aurora, the Roman goddess of dawn, and Boreas, the Greek god of the northern wind. Together, Aurora Borealis. Scientists at the time speculated wildly. Some thought the lights came from sunlight reflecting off polar ice. Others believed were gases rising from Earth's surface and catching fire in the air. Even great thinkers like Edmund Halley of Halley's Comet proposed that magnetic vapors in the upper atmosphere might be the cause. They were close, but the real answer would come from space. Our story truly began 150 million kilometers away on the surface of the sun. The sun looks calm from here, but up close it's a roaring, boiling sphere of plasma, a sea of charged particles constantly exploding and flowing outward in every single direction. This endless stream is called the solar wind. Every second, the sun releases billions of tons of matter into space, mostly electrons and protons racing outward at speeds over 1 million kilometers per hour. When the solar wind reaches Earth, it meets our invisible protector, the magnetosphere. Earth's magnetic field deflects most of these particles, guiding them harmlessly around the planet like water around a rock. But near the north and south poles, the field lines curve inward, allowing some of that solar energy to funnel down into the atmosphere. When those charged particles collide with atoms of oxygen and nitrogen, they transfer energy, and those atoms release it as light. The color depends on which element is excited and at what altitude. Green and yellow come from oxygen about 100 kilometers above Earth. Deep red appears from the oxygen even higher up, around 250 kilometers or more. Blue and violet are produced by nitrogen molecules, often outlining the lower edges of the aurora with an electric shimmer. The result is a vast curtain of light, an invisible magnetic storm made visible to the human eye. It's astonishing to think that what we see as beauty is actually the visible echo of solar violence, a reminder that we live in the path of a star. Auroras follow invisible patterns, giant ovals centered around Earth's magnetic poles, called auroral ovals. When the sun is calm, those ovals shrink, and the light stays near the Arctic Circle. In places like Alaska, northern Canada, Iceland, Norway, and Finland, it's certainly more prominent. But during powerful solar storms, when the sun hurls out huge bursts of plasma called coronal mass ejections, the ovals expand. The lights can spill much farther south than typically they would, sometimes reaching as low as Scotland, the northern US, and even Central Europe. When that happens, entire cities look up in disbelief. In 1859, one of the strongest solar storms in recorded history, known as the Carrington event, produced auroras visible as far south as the Caribbean. Telegraph lines sparked and caught fire. Operators received shocks through their equipment. The sky was said to blaze like dawn long before sunrise. If an event of that magnitude happened today, our satellites, GPS systems, and power grids could be severely damaged. The aurora is beautiful, but it's also a warning. A reminder that Earth's magnetism shields us from a sun that, if left unchecked, could strip our atmosphere away quite quickly. For those who live in the far north, the aurora is part of life, a familiar mystery. But for travelers, it's a pilgrimage. Every winter, thousands journey to Iceland, Norway, Canada, and Alaska, hoping to catch a glimpse of the sky aflame. They check solar activity forecasts and bundle up in layers, and then drive far into the wilderness, away from the glare of the city lights. Photographers wait with their cameras poised, breath visible in the cold, fingers surely numb on the shutter release, waiting for that moment. And then suddenly a faint band appears on the horizon, and it grows, shifts, and bursts into a curtain of color stretching from one end of the sky all the way to the other. The lights ripple like silk, twisting into shapes that seem almost deliberate, as though the sky is alive and breathing. Even in an age where we can live stream from Mars, the aurora still feels like a miracle. Every sighting is fleeting. The lights might last for minutes or even hours, then vanish as suddenly as they appeared. And that's the part that makes them so haunting. They're not guaranteed, they're not controlled, they're just borrowed moments of cosmic light. Behind the poetry, though, there's physics, and it's more complex than even scientists first imagined. Space agencies like NASA and the European Space Agency have sent fleets of satellites, missions like Themis, Swarm, and Cluster to study how solar energy interacts with Earth's magnetosphere. They've discovered that auroras are part of a much larger system, magnetic storms that can encircle the planet, sending energy cascading down through the atmosphere like invisible lightning. In some cases, the aurora's flickering movement is caused by Alfvén waves, ripples of magnetic energy traveling along the field lines from space to Earth. These waves accelerate electrons downward, creating bursts of light that dance in sync with the planet's magnetic heartbeat. In short, every time the aurora shimmers, you're watching the pulse of our planet interacting with a star. While the northern lights steal most of the attention, there's actually another show happening in the opposite end of the world. The Aurora Australis, the southern lights. They're identical in every scientific sense, mirroring the northern lights across Earth's magnetic equator. But far fewer people see them. The best views are from Antarctica, Tasmania, and southern New Zealand, remote windswept places where the nights are long and dark. Satellite photos show both auroras glowing at once, pulsing in near-perfect symmetry, proof that what happens in the north is echoed in the south, like two mirrors reflecting the same solar storm. There's something profoundly human about that idea, that across the vast divide of our planet, people separated by oceans and ice can still stand beneath the same storm of light. For millennia, the aurora has inspired more than myths and measurements. It sparked art, poetry, and even music. Painters in the Romantic era tried to capture its fleeting glow on canvas. Writers like Jack London and Philip Pullman used the lights as symbols of wonder and mystery. And in modern times, the aurora's colors have found their way into everything from national flags to pop culture. A shorthand for awe, for beauty, that's well beyond our control. Even in indigenous cultures today, the oldest stories persist. The belief that the lights carry messages from ancestors, or that they guide spirits between worlds. These traditions remind us that science doesn't erase meaning, it just expands it. Knowing the cause doesn't make the aurora less miraculous. If anything, it deepens the wonder. Because the truth is even more astonishing than myth. Every aurora you see is unique. The shape, the color, the rhythm, all determined by a combination of solar winds, magnetic fields, and atmospheric chemistry. No two displays are ever identical. Yet they've been happening for billions of years. Long before humans, long before even life crawled from the oceans, the lights were already dancing in Earth's skies. They're among the oldest continuous performances on the planet, an ancient rhythm that connects our deepest past to our bright future. When you watch the Northern Lights, you're seeing the same phenomena that once shimmered above mammoths and glaciers. It's humbling and somehow comforting to realize that the sky has been keeping the secret show long before we arrived to even name it. From ancient legends to atomic collisions, the Aurora Borealis bridges the worlds of science and spirit. It reminds us that beauty doesn't always need a reason, but when it has one, that reason can be extraordinary. The aurora is proof that we are part of something vast, that our small, spinning world is connected to a star through threads of invisible energy and light. It's a dialogue between heaven and earth, and we, the viewers, are lucky enough to listen. So if you've ever found yourself in the far north, some quiet winter night, away from the city lights, under a sky so cold it crackles, well, look up, because for a few fleeting minutes, you might see the universe dance in front of you. Our journey through the Aurora Borealis comes to a close, but the night sky still has its secrets. In 2 weeks, the Tilted Planet podcast returns with a special Halloween episode, a journey into the dark heart of Europe's folklore, where myths and shadows meet. Episodes will also now arrive every other week, allowing a little more time to dive deeper into the stories that shape our world. Until then, keep exploring, keep wondering, and tilt your perspective. And if you've enjoyed today's episode, please consider leaving a comment, a like, or a review. And you can also support the show through buying me a coffee in the link in the description.